So this is going to be chapter 3.5, number 10. This one says to do it on paddy paper, and I'm not going to do that because you don't need to do it on paddy paper. You have 3 fire stations in this county. And, you know, again, the question doesn't really require absolutely that you make a perfect copy of the picture. It's really more the idea that we're talking about. And I'm going to name the fire stations A, B, and C. Now, if you have a house in this county that catches fire, this is a weird place. They're fire trucks. They're actually not trucks. They fly their fire trucks. So they go straight line from wherever the fire station is to wherever the fire is. It doesn't matter where the roads are. They just go straight. But you need to figure out which station you're going to call. So if your house is here, they don't have a dispatcher. Well, okay, maybe they do have a dispatcher. The dispatcher has to figure this out. Or maybe they need to figure it out in advance.
If it's so small, why do they have 3 fire stations?
It's not.
It's a very large.
At what point did I tell you how big this was?
Well, it just looks really small.
It's not.
Okay. So you see where I'm pointing with my pen? If your house is there and it catches fire, which fire station do you want to have respond?
B, because it has a better reputation.
Oh,
Hey, they're faster.
Okay, there's an answer I'm fishing for here. The answer is A, as you know. What about if you're here?
Definitely
A. What about here?
A.
B.
I prefer D.
B.
B.
A. Or both.
Which one is closer?
B.
A.
You don't know.
I am trying to put my pen right in between them, as you know.
I have an idea. How about we just like flip a coin?
Right, it's undecided. They're really, what's the word for this point on the map with regards to A and B?
Bisector.
Midpoint, bisector, it's also equidistant, halfway. Okay, well here's another way to put this question. Suppose your house is here.
B.
Well, these are 2 points. A and B are 2 points. My finger is a 3rd point. So it doesn't really, it's not bisecting anything. There's no segment that we're talking about yet. But it is equidistant. Like a perpendicular bisector? Yeah, one of those. So if you had a segment AB and you constructed a perpendicular bisector, that perpendicular bisector would be all the places where it would be a coin toss whether you want to go to A or B. So we can actually, that's part of our decision-making process. We can treat that as if it were a segment, and we can construct a perpendicular bisector for it. So now, anything on this side of that line goes to B. Anything on this side goes to A. Now, how come I didn't draw the line all the way down here? We're getting closer to C. So, how do we decide between, say, B and C? All right, we'll do the same thing. Yeah, I blew it. I did the same thing this morning, too. Completely botched that. So I'm going to draw that just up to this point, because once I go on the other side over here, maybe I'm going to be closer to A. But certainly on this line, if I'm on this side, I'm in B territory. I'm on this side, I'm on C territory.
What happens if it's right in the middle?
You've got a real decision to make there.
What if you're just out of this country?
And you go to D.
E. Huh. Now, no, look at this. This third line is going to the same place. That's amazing. This is like the center of the triangle, isn't it?
It doesn't look like.
Well, so it's closer to this side than it is to that side. So in terms of being in the middle of all three sides, it's not a center. But what can you say about its distance from the three fire stations?
It's closest to A.
Is it?
No, I think
What's
it's
it?
exactly.
Let's try something.
B compared to A. B looks so much smaller.
I'm going to measure the distance to A from that center. Watch closely.
Oh, it was closer.
Yeah.
Did I say?
C was the furthest. Except look at like the area that B is compared to A. A has so much more area.
So if I had done this really carefully, I would find that the circle goes through A, B, and C, which means that this point is the same distance from all three fire stations. So that is the place where you really have no way of making up your mind which fire station it is. So you see how this circle goes all the way around the triangle? It touches all three vertices, but it goes on the outside. Do you remember a term for a circle that does that? Have you ever seen that before? Circumscribed circle. So it goes it goes around, and the name for this center point, it's really clever, is the circumcenter. And you construct a circumcenter by finding the point of concurrency for all three perpendicular bisectors of the sides. This is a neat thing. So that point is equidistant from all three vertices, and it describes a circle that goes all the way around the outside. We're going to be looking at that again on Monday in more detail, and then we're going to look at some of the other centers for triangles. So in the end, you've got a map here with three regions defined. One that's every point in it is closer to C than any other fire station. And you've got this region over here where every point in it is closer to B than to any other fire station. And then you have this region where every point in it is closer to A than either fire station. So there you have it, a practical application of geometry. If you ever need to plan the response map for a county with three fire stations where roads don't matter, you have just the tool for it.